We often view mathematics as a cold, mechanical process, a series of calculations performed by a human machine. However, the people who dedicate their lives to the field describe their work as a search for symmetry and aesthetic perfection. The mathematician Paul Erdos believed the universe has a natural preference for brevity. He spoke of the book, a theoretical text containing only the most elegant and succinct proofs in existence. In this world, a correct answer is only the beginning. A solution that relies on brute force, checking every possible combination through sheer computing power, is seen as ugly. Mathematicians are looking for something cleaner. Researchers used an fMRI machine to monitor mathematicians as they viewed complex equations. They found that these formulas triggered the same emotional pleasure centers in the brain as a Mozart sonata or a Da Vinci painting. This neurological response suggests that for a professional, the aesthetic quality of a solution is a primary indicator of its depth. To them, the most beautiful answer is often the one that captures the most truth. What specific traits elevate a string of numbers into a definitive mathematical breakthrough? There is a specific analytical framework used to evaluate these works, built on 3 pillars: simplicity, unexpectedness, and unification. When an equation meets all 3, it stops being a mere calculation and begins to reveal the underlying architecture of reality. The first pillar is simplicity. An inelegant proof is like a corn maze where you can't see where you are going. A masterpiece turns that maze into an open road. In the 19th century, Carl Friedrich Gauss developed a way to add quadratic expressions together. While his composition law was brilliant, the proof required 20 pages of dense, nearly impenetrable calculations. When Manjul Bhargava encountered this work as a graduate student, he was struck by the gap between the importance of the law and the brute force ugliness of the math used to reach it. Bhargava realized he could map these numbers onto the spatial geometry of a Rubik's Cube. This visual insight allowed him to bypass pages of algebra and solve the problem with a single, elegant observation. True simplicity doesn't ignore complexity. It cuts through the noise to expose the foundational structure underneath. The second pillar is unexpectedness, the shock of discovering a hidden connection between 2 completely isolated worlds of thought. Euler's identity is frequently cited as the most beautiful equation ever written because it creates a bridge where none should exist. This diagram shows the disparate concepts in the formula. E represents continuous growth, I is an imaginary number, and pi is the geometry of a circle. These complex, unrelated constants synchronize to return the math to its most basic foundations, the numbers 1 and 0. The beauty of this result comes from the realization that these random, disconnected rules are actually parts of a single, synchronized system. The final pillar is unification. A masterpiece forces us to build bridges across the mathematical landscape. In 1637, Pierre de Fermat claimed a simple equation had no whole number solutions. That claim, Fermat's last theorem, remained an unsolved mystery for 358 years. Andrew Wiles spent a decade in isolation working to prove it, eventually finding the answer by connecting 2 distant areas of mathematics. Wiles succeeded by linking 2 previously isolated continents on the mathematical map, elliptic curves and modular forms. This revealed that these distinct disciplines were actually different expressions of the same underlying structure. Unification shows that our human categories are an illusion. A true masterpiece proves the structure is one whole, unbroken web. This raises a question that has been asked millions of times. Are these breakthroughs invented by us, or are they discovered? History shows these patterns often emerge independently. The ancient Indian Chakravala method solved complex equations centuries earlier than the European methods we now use. Srinivasa Radhanushan claimed his formulas for infinite partitions were simply revealed to him, pulled directly from a source he could observe but not control. The universality of these breakthroughs suggests that we are uncovering a logic that was already there, existing whether we are here to observe it or not. These proofs offer a glimpse of what philosophers call the sublime, the realization of a consistent underlying order beneath the noise of the physical world. Albert Einstein famously observed that pure mathematics is, in its way, the poetry of logical ideas. A mathematical masterpiece shows us the universe speaking in its native internal tongue. In these moments of clarity, we are no longer just measuring the world, we are finally understanding it.